Alrighty, so this thing managed to load onto the launch pad just fine. Pay no attention to these floating little doodads there. Everything's perfectly normal. Okay, so what we have here, first and foremost, is a whole heck of a lot of stacked umbrella radiators. We're going to leave those folded until we get into space. Underneath of these is a regular old magnetic scoop. Regular old Yale magnetic scoop. Okay, and then cascaded, scaled up and incrementally down radiators. If you can kind of peek in there, you can kind of see that they kind of just taper down to a point. You got your warp core, you got your big, sheet radiators. Down in here, we've got a muon catalyzed fusion reactor, scaled to, where is it? Should be 3.75 meters. Oh yeah, I gotta open the reactor control window. There we go. 3.75 meter muon reactor there. We also have another muon catalyzed fusion reactor up top. We have this one scaled to 5 meters. That's going to be important later on. Gonna switch these to a different mode, but for the launch we're going to leave them on proton deuterium because we have enough in reserve to make those happen. We've got a couple of centrifuge rings. On each side we have a positron factory. So the centrifuge rings can make antiprotons, and then we can make positrons here in the cyclotron. So that's going to be important later. We have all manner of fuel tanks for gases and liquids in pairs. So we've got ammonia, we've got carbon dioxide, we've got your liquid ammonia, you got your nitrogen, hydrogen, of course. The hydrogen's the only one we're actually really starting off with besides what's in the reactors when we start off. Everything else we've got empty. Hydrogen peroxide, hydrazine, there we go. It's right there. Some oxygen. Each one of these gas tanks holds a different gas. So ammonia, helium-3, carbon dioxide, deuterium, oxygen. I think there should be a carbon dioxide and a carbon monoxide. Yeah, okay, alright, so we got both of those. And all of this is going to come into play once you see what this thing is for. If you haven't guessed by now with the magnetic scoop and the name Helioplease and the muon fusion reactors, this is going to be a power station. And we're going to convert energy into X-rays and zap it off into space for other things. But this is also going to be essentially a star forge. We're going to park it near a star, and then we're going to use everything that we collect from it, from here, in order to create other materials that we might need. Everything from, we're going to collect hydrogen and helium, and we're going to turn helium into carbon. We're going to turn the carbon and helium into oxygen, which we're then going to combine with the hydrogen that we collect, and we're going to make hydrogen peroxide, which we're then going to run across, some other stuff. Ammonia, yeah, we're going to collect nitrogen and hydrogen and make ammonia, which we're going to use to make hydrazine and water. And with water, we're going to use that to convert carbon monoxide and carbon dioxide, scrape off a little more oxygen from that, and just keep perpetuating the process ad infinitum, and basically create everything we ever would need. Lithium, you can make lithium once you've got enough helium. I think it was like helium and hydrogen, or maybe it's helium and deuterium. One of those, you smash them together, you end up with lithium, which is pretty cool. So you're probably looking at this and you're like, how do I get this into space? Do I load this onto a rocket? Do I build it in orbit? What do I do? Oh yeah, gotta have the capacitor. Supercapacitor is a must on all these things. So what you're gonna do to get this into orbit is you're gonna open up your warp drive. Okay, and you're gonna put that right there. Let's go ahead and, well, we don't really need this open right now. So we're going to do that, and first thing we're going to do is auto hold altitude. We're slowly going to charge up. As you see over here, going to be just about ready here pretty soon. You can see we're starting to gain a little bit of heat, and when we're confident that we're fairly charged up, we're going to go ahead and release the launch clamps. And we're buoyant. Alright, so we're going to go ahead and kick that up to 110%. Scratch that, 115%. And there we go. Okay, now a little bit of interference there from the launch clamps. Couldn't really do a whole lot about that without adding extra, struts and pylons and stuff. But more or less, we're going to eventually float free of the launch clamps. There we go. A little bit of minor adjustments, make sure we're pointing up. I'm using the keyboard here real quick to hit A, hold A rather. And there we go, we're slowly inching our way towards pointing up. And once we're more or less pointed up and our prograde across the surface is pointed up, we're going to try to hold that as much as we can. There we go. Alright, so we're going to stay right about there. I'm not really going to lock it until it's perfectly centered. But just like that, with your warp core overcharged beyond what it needs to actually achieve warp, you're going to start floating away. Just overcharge it above 100%, and you're going to start floating away. I'm going really slow with this. 20 meters ish, 21 meters per second. Real slow ascent because this thing is obviously going to spin out of control and get all kinds of wonky if I try to go fast. Once it's out of the atmosphere, no problems. We just activate the warp drive, warp away, and don't even have to worry about circularizing the orbit until we reach our destination, which it will do for us. So it's pretty cool. You build a giant station, get it nice and even and centered and whatnot, and you just float it up. Now this is going to take a while. A whole heck of a long while. So what I'm going to do for you, so you don't have to watch the whole thing, I am going to float this thing entirely into space without cheating, just to do it. But I'm going to go ahead and speed up the playback there when I upload this. So when you watch it, it will be in 4 times speed or something of that sort, 4 times, 8 times, however fast I need to speed it up in order for you to see this thing get into orbit continuously without me cutting away. So I'm just going to keep on recording, and then it'll speed up. I won't talk over that part. I'll probably dub something in afterwards is what I'll do. So it'll be cool. All right, so we'll go ahead and we'll watch this slowly make its way up. I might make some adjustments as we get higher to make it ascend faster, so you'll see that. But this is basically what's going to be going on for the next few minutes. Feel free to skip ahead if you don't want to watch the launch phase, and we'll get to the positioning phase around Kerbal, the sun, and we're going to deploy, start collecting things, and I'll show you the refinery and what all we can do, and basically how you can use this, something of this nature to construct anything or to produce all the late game fuels that you will need. Okay, and we're back. I had to reload a couple times. This craft is a little bit too much, so these radiator fins kept breaking off when I entered warp, so I had to do a real quick test run. So once we cleared the atmosphere, I turned the warp drive off, allowed it to cool down a little bit, and then I charged it back up and just kind of zipped away from the planet a little bit of ways to establish an orbit. So we're up there, just kind of hanging out. But we are in orbit and nothing fell off, which is great. So next thing we're going to do is we're going to kind of point, not directly at the sun, but hopefully MOHO is in a good orbit for us to use as a target, and it totally is. So we're going to kind of point at MOHO and then purposefully miss MOHO. So we kind of slide through here and then maybe park in this general vicinity over here to give us a nice good orbit. We'll see what happens. It's going to take a moment here to turn. It's a big craft with no RCS, no engines of any kind, just the warp engine and the reaction wheels from the warp engines is all that's really turning this thing around and allowing it to move. So it's pretty neat in that aspect. No crew on this station. It's got an AI unit somewhere tucked away. I think that's it right there. Yeah. There's a computer core here. It's named Aleph. Aleph is our computer core. The AI is currently on. So this is going to get into position, park, start manufacturing materials, get life support like water and oxygen and that sort of thing up and running before any Kerbals actually crew the crew modules. Alright, so we are pointed generally at MOHO. We're going to turn off stability assist and just kind of point a little away so that we don't run directly into it. Doesn't really matter where, we can adjust our orbit later, but we're just going to point a little off for MOHO and start charging our drive. See those radiators getting nice and hot. Okay, and we activate, and we are off. That's it. Just like that, a space station was constructed on the ground, put into orbit, and then is off towards its destination, all in one stage. No thrusters required. Now let's go ahead and increase our speed. 10 times the speed of light. Oh, and that there might happen. Those trusses, I tell you, they didn't quite hold up as much as I was hoping that they would. But we're going to go ahead and continue with the experiment, minus a few fuel tanks. Oh my, which one was that? Carbon dioxide. Okay, that was our carbon monoxide tank, which is actually not that big of a deal because we have room to store carbon dioxide here. So we can turn this carbon dioxide tank into a carbon monoxide tank, and the other one there, that's hydrogen peroxide. We have 5 more of those. So we're totally fine. As far as heat dissipation, that's kind of an issue. That's going to mean we're going to be running lower power, lower efficiency, but not the absolute end of the mission. So we're gonna plug along and see if we can't accomplish what we're trying to do here anyway. All right. So first thing we want to do is we want to flip around so that we're facing the opposite direction, and put our collector here facing the sun. Let's go ahead and deploy. Wonderful, wonderful. And let's check our orbit real quick, make sure we're at a good altitude. We're honestly a little far away. We could be closer. We might not be a terrible idea to get closer, but let's before we do that, we'll we'll double check and make sure we're gathering materials. So we go to the big all-in-one refinery. This also has a refrigerator unit. And this is so that we can still process solar wind when the refinery is doing other things, which we'll get to. Alright, so first thing we're going to do is start processing solar wind. Make sure we enable overflow, and we are already collecting lots and lots of materials. Every material on here: hydrogen, helium, carbon monoxide, nitrogen, neon, deuterium, and helium-3. All of those are going into our tanks, and we're going to slowly start filling it. We actually ended up coming here with nitrogen already, so it's not going to give us an accurate count of how much nitrogen we're collecting from the sun, since we already started off with a bunch, like, you know, almost 3 kilograms. And that comes in the centrifuge rings right here. I should empty that out before I left, but I totally forgot. But that's quite alright. Alright, so what we're going to do, now that we are collecting, we're going to double check here, see if we get any extra stuff from ionization. Oh, that's interesting. Alright, take a look at helium-3 up here. It's at negative 0.06 right now. If I turn ionization off, it goes to negative 0.03. So with ionization on, we are producing a lot more helium-3, but I'm actually thinking that's actually an artifact of the reactors, because the reactors are producing helium-3, up the power, and it's going to produce more. So what we're going to do here is turn this to the CNO cycle. That did not reduce our helium-3 production, so let's go to this other one. Reactor control window, CNO cycle. Yeah, okay. So we're not getting extra helium-3 from the magnetic scoop. What we're with ionization on, what we're doing is we were just burning that particular reaction a little harder. So we're going to turn that back down, since it doesn't actually do anything for us. And the smaller one, I'm actually going to put back on proton deuterium, so that it continues to produce helium-3, and we're collecting, you know, deuterium and hydrogen in abundance, so we have, you know, thousands of years to run that on. And this one's going to run on the CNO cycle, so it's got 646 climbing, 47 years of hydrogen. So it's basically these guys in this mode can run, you know, more or less forever. So we're going to leave that off. Check our power, and that gives us, you know, 19 gigawatts to play with. So that's fun. So what can we do with that? Okay, one thing that we can do, since we are just scooping up all of this solar material, and that solar material comes in the form of hydrogen, helium, carbon monoxide, nitrogen, neon, deuterium, and helium-3. The neon we can use in the muon catalyzed reactors here, so that you know, they can run in neon mode. That's one thing we can do with that. Helium-3 and deuterium, obviously you can use those for all sorts of things. You know, you can use them in fusion, and you can also use them to create fusion pellets, in case a vessel came along and wanted to, you know, do fusion pellets. And simple enough, as you collect deuterium and helium-3, you liquefy it. So you go to your refrigerator unit, and you liquefy your helium-3 and your deuterium, and actually it looks like I might have lost more tanks than I considered. Liquid ammonia, liquid ammonia. Okay, so I need to change this to helium-3. There we go. Liquid helium-3 can go in here, and then I would be able to liquefy it, and then I can just change this one to deuterium. There we go. Okay, so now we have all the storage tanks, and I could then turn on the refinery window, or not the refinery window, sorry about that, guys. Turn on start create fusion pellets, and it would you know, start making those if I had the liquid helium and deuterium, or liquid helium-3 and deuterium in abundance. But it's going to take a while to collect. You might be wondering, why am I bothering collecting carbon monoxide? Well, that's where the fun chemistry comes in. So we're going to deactivate that, and I'm going to turn on the solar wind processing just on the refrigerating it. It doesn't work as quickly, but it's going to just keep running in the background while we're looking at this. So if you have the resolution up on this playback here, you're going to notice, a lot of different things that you can do. One thing that you can do is called the water gas shift. This uses water and carbon monoxide gas to produce carbon dioxide and hydrogen gas. Okay, so we're going from carbon monoxide to carbon dioxide. What are we going to do with that? Well, from there, you can do carbon dioxide electrolysis, which is going to give you carbon monoxide again, and then free, O2 molecules. So you're going to go from carbon dioxide and water to eventually just free oxygen. But here's the catch. We don't have any water. We can't collect any water. So where are we going to get the water from if we don't have any oxygen to begin with to start the process? Well, what we do have is the anthracene process. Okay, that'll take hydrogen gas and oxygen gas, and it'll produce hydrogen peroxide, which we can then react with ammonia, through which we can gain through the Haber process. And once we've done the Haber process, we'll turn hydrogen and nitrogen into ammonia. We run peroxide and ammonia, and we'll get hydrazine, and we'll also get water. Okay, and then we can use that water to do this, to get more of that, to make more of this, and it just keeps going. And we're gonna need that initial spark, if you will, of oxygen that is not already bound to a carbon molecule, because that's all we've got right now is oxygen bound to a carbon molecule. So where do we get that? Well, that's where the centrifuge comes in. So ye ol' Starforge, right? Okay, so we look at our fusion modes, and we can make some cool stuff. You can make some lithium, carbon. Smash some helium together, and you get carbon. Okay, well, what do we do with that? I don't see oxygen on here. Well, that's because we don't have the materials for it. So first thing we do is we take helium, which we are collecting in abundance. We have tons of helium just hanging out here, right? And we turn that on. And suddenly we are producing carbon. Okay, cool. Let's do it again. We have 2 of these rings, so why not, right? Alright, so both of these are going to fuse helium molecules, helium-4, not the fancy helium-3 stuff, but just plain old neutral helium-4, and they are both going to produce carbon. As you can see, it's not a lot. It's really not a lot. We've got, the micrograms or whatever that is. I think that's a microgram. UG? Is that a microgram? I'll look it up on Google in a minute. Anyway, we've got our first milligram of carbon. So that's cool. And once we get about 2 milligrams, we're going to switch one of these over. Pardon me while I combust a little bit of carbon and oxygen on my own. Okay, so getting close. Let's go ahead and turn this off. Next fusion mode is helium plus carbon gives you oxygen. What do you know? 6 protons in the carbon atom, 2 protons in the helium atom. 6 plus 2 equals 8, which gives you the 8 you need for an oxygen atom. So you just smash them all together and start producing, and voila, we are producing 170-ish milligrams of oxygen per hour, with the carbon reserves at 2.35 milligrams and climbing, because this thing is still producing carbon. So we are continuously collecting helium, which we are then fusing into carbon, which we then fuse with more helium, and we get oxygen. And so our oxygen reserves slowly fill. We've only got 1 milligram of oxygen right now, so we're really not that far. It's going to take a while. So if we go ahead and time accelerate, we'll see if we can't collect a decent amount of oxygen before we lose alignment and have to adjust. You can see over here, oxygen's slowly climbing. We have 3 units of gaseous oxygen now. Still not a lot. Still not a lot. But potentially, if this thing's up here long enough, it'll collect a good amount. We've been here for 2 days now. That's right, I should turn the other refinery on so that it is also processing that solar wind. Okay, there goes that. Okay, so after almost 3 days, we have 8.65 units of oxygen. Not a ton, but with patience and diligence, you know. And you just keep this thing running. I'm just going to turn these off. Just going to keep them running in the background. When we check our power, you know, we're hardly using any power to perform this operation, because the centrifuge rings are basically performing a fusion reaction of their own, which generates enough power plus like a few kilowatts to sustain the reaction on their own. So once it gets started, these don't cost you anything extra in terms of power, because they produce their own through the reaction. You just keep feeding it helium and carbon or helium or whatever, and it'll just keep going. Alright, so we have a ton of carbon monoxide here. So 1,270 units of carbon monoxide, 8.65 units of oxygen. Okay, so let's see if we can do anything with that tiny amount right there. Okay? Alright, so first things first, we want to make water. Now you're probably thinking, like, why? Well, I'm not using any life support mods, but certain things require liquid water. You just kind of want to have it, and plus it's a good way to store hydrogen and oxygen. But you know, we're just going to do some chemistry just for the fun of it. So let's see here. We want to make hydrogen peroxide. We're going to use that free oxygen and the hydrogen that we have here, and we're going to make hydrogen peroxide. So we do that, and we didn't have a whole lot, but that gave us 0.01 units of hydrogen peroxide, which got stored in one of these tall tanks here. Yeah, so there's like 2.5 grams in that tank. There's 2.5 grams of hydrogen peroxide in that tank. There's a teeny tiny amount. But still, we have, you know, well, 2.5 times 5 grams of hydrogen peroxide. So it's really not bad. All right, so once we've got the hydrogen peroxide, the next thing we have to do is we have to make some ammonia. So if we go over here to the Haber process, we are producing ammonia. And let's see, gaseous ammonia. Do we have liquid ammonia anywhere? Yeah, but that's not filling up. All right, so we have gaseous ammonia. And that was all of our nitrogen. All right, so we deactivate that. All right, so we have a teeny tiny bit of ammonia. 5,309 units translates into 4 kilograms of ammonia. So with our, you know, 2.5 times 5 kilograms of hydrogen peroxide, that gave us enough for some ammonia. But what else can we do? We need that water. So now that we have peroxide and ammonia, we go over here and we have produced just the teeniest drip of hydrazine and water. So let's deactivate that process and check. Alright, so we have 3 hydrazine storage tanks. Each one is going to have 6 grams of hydrazine. So we produced 18.6, you know, because there's the 0.2 right there, 18.6 grams of hydrazine from our initial reaction there. And as far as liquid water goes, we have 3.5 grams of liquid water. Cool, huh? And that's in each of these containers, of which we have 6. So that's what, 18, 20, I don't know, it's a bunch. I don't do math, so it's 0.1 to 0.03 units of hydrazine, and then liquid water, we've got 0.02 units. Pretty cool. Now, once we've got liquid water, we can react that then with the CO, the carbon monoxide, and that'll give us carbon dioxide and hydrogen. But you're probably thinking, why are you going to use up your precious, precious water to do that? Because chemistry. So we're going to go ahead and do that. And we've reacted all of our reactants there, and that gave us carbon dioxide and hydrogen gas. So carbon dioxide in the amount of 26.29 units of gaseous carbon dioxide, which gets stored right here in the refinery. Then go over here to carbon dioxide electrolysis, right? That's going to give us CO back, and then we're going to get some free O2 from it. And boom, free O2. And with that free O2, free oxygen, we received 13.23 units of oxygen. And then we can just keep on going in a circle, incrementally producing ever so slightly more hydrazine, and then coming back and just doing it all over again. And then from there, you can use that to refuel ships that would need hydrogen peroxide or hydrazine as their propellant. Incidentally, we could also create methane here very, very easily with just one more step in that process. Just don't do the electrolysis of the carbon dioxide. Instead, react it with more hydrogen, and you'll get free O2 very quickly, and then you'll get methane. So that's another way of doing it. I don't have methane storage on here, but I could easily repurpose a tank. Let's go ahead and do that, and move that there. Do that. Okay, let's see, methane, no. One of these will be methane. Methylene, oh, oxygen, we'll just go straight methane. Okay, there we go, liquid methane is what we have right here. Don't know if we're going to need gaseous storage for methane, but we'll find out. So Sabatier process, CO2 plus H2. We don't have any CO2, so we need to make more. Do a gas shift, we don't have any water, so we have to make more water. Yeah, okay. So let's do this over again. Alright, so where was the water? That one, right? Oh, we don't have any peroxide. I totally forgot the process. Okay, let me do this again. Alright, so we start off. Let's just make some. Oh, that's right, we're missing nitrogen. Sorry, folks. How much nitrogen are we getting? 6 grams of nitrogen per hour. Alright, so it'll take us a minute to refill back up on nitrogen. But just go ahead and watch the process over again. I should have came out here with larger fuel tanks so you could get a more of an idea. But basically, you stick this guy out here for, ever. Not forever, but for a few days. And just let it cook. Zoom that up a little. That's saying we ran out of fuel. That on CNO. Yeah, they're fine. Plenty of hydrogen forever, so we're good. A little tricky in the time warp there, but that's okay. Let's see, carbon monoxide, hydrogen. Where's oxygen? 19.93 units of oxygen, 257 units of nitrogen. Okay, all right, let's try this one more time. Go into the refinery. First thing we're going to do, we're going to make some ammonia. There we go. We made all of our ammonia. Good. Next thing we're going to do, we need peroxide, we need oxygen. Oh yeah, these things should be making oxygen for us. So that's making carbon. And then this one should be making oxygen. Yes. Excellent. Okay. So that's going. So we've got enough now, so let's do. electron process, got all the hydrogen peroxide. Go down here, peroxide process. Got all of our hydrazine, got a little bit of extra water. Water gas shift, got a little bit of CO2. Sabatier process, CO2 plus H2, got a little bit of methane, got a little bit of oxygen back. So from the oxygen back, a little more HTP, done. And from the HTP to the hydrazine, done. And we should have a little bit of water left over. Let's double check. We have 0.2797 milligrams per tank of liquid water, which is definitely not very much. But nonetheless, we have it. And through that method, you just keep doing that, and it's going to continue to produce carbon and oxygen for us to continue that process. From there, though, we're now up to 20, 40, 61.5 grams of hydrazine, which is really neat. And I think we have ammonia up here somewhere. Oh no, we've used all the ammonia, making the hydrazine. So we ended up with 0.06 units of hydrazine, and not quite a unit of water. But scale the process up. Bigger refineries, bigger collectors, more power as usual, and it will most definitely just continually produce things out of nothing but star stuff. And all that's great and good, but what's this thing for? We have a free electron laser, X-ray free electron laser. Can do anywhere from long soft X-rays, middle, short, near hard, middle hard, and far hard X-rays. These have the least amount of absorption from water, but they will all be completely absorbed by an atmosphere. So you can't really use these to beam power to a planet. These are more for beaming power to vessels that are in flight in space. But you can produce some good results there. So let's take a look here. Remember, we're running the muon catalyzed fusion reactors, a 5-meter one and a 3.75 meter fusion reactor in tandem, giving us a decent amount of electrical power that we can have access to. So if we were to turn on our transmitter, it's gonna not quite want to use all that power, because it'll definitely cause us to start losing efficiency. So we take a look at that and we just scale it down until it stops losing power, is what I like to do, because that tells me that it's not overheating anymore. Probably gonna have to go down pretty low. .85. Seems pretty stable. Yeah, that looks pretty stable. Okay, so at 14.5%, with the rest of the solar wind processing and collecting going on, and the carbon and oxygen manufacturing as well going on, we still have enough left over to pump out almost 2.5 gigawatts of power. It slowly loses efficiency as it overheats. We might tune that down just a hair more to 13, just to keep it. 2 gigawatts plus is definitely plenty. From this orbit, we could get a good amount of that to curb in orbit, and the craft would have plenty of power. Not so much if we were trying to send this to another star system, but still plenty to work with for a lot of things. But that's pretty much it for this particular station. Today we covered launching into orbit using nothing but the warp drive, positioning using nothing but the warp drive, and then once in position, a little more on the magnetic scoop, and continuous fusion reactions using the cyclotron and the the ISRU refinery so that you can produce all the late game fuels and materials that you could possibly need. You don't really need uranium or thorium or that sort of thing at this point, because your fusion reactants are way better, and they're free. So yeah, if you have any questions on this, or you have another idea you want to see explored, let me know in the comments or through a direct message or something like that, and I'll make a video for you. Until then, keep flying, have fun.